Okay, welcome everyone. Welcome to my YouTube channel, Maths Made Easy with Terry in 10 minutes. Okay, here we're going to talk about binomial expansion with negative and fractional powers. Okay, now just a quick note: in the previous video, I told you about binomial expansion with positive powers. Okay, so if you not watched that video, please go back and watch it and try to understand the previous videos in this series before coming here, because I've built it up to this point. Okay. Okay, so also in the previous video, I also explained to you that when n is a positive whole number, it has a finite number of terms. So for instance, if we have x plus 1 raised to the power 3, it's going to be x raised to the power 3, 1 raised to the power 0, plus x raised to the power 2, 1 raised to the power 1, plus x raised to the power 1, 1 raised to the power 2, plus x raised to the power 0, 1 raised to the power 3. Is that making sense? So we know that for when it's raised to the power 3, we're going to have 4 terms. So this is going to be the first term. This is going to be the second term. Okay. This is going to be the third term. And that will be the fourth term. All right. So those are the number of terms you have. But the problem now is that when n is negative, it seems not to end. So for instance, you can keep on going, you can never get to 0 because it's already less than 0. Does that make sense? So it's already less than 0, so you can't have a definite number of terms. So in order to avoid this, usually we have 3 rules I always talk about, all right? I always talk about 3 rules. When you want to solve these questions, have these 3 rules in mind, or 3 steps, okay? And it's going to help you very well with this, all right? The first rule is that when you want to solve it, make sure, all right, that the format inside the bracket must be 1 plus something. So that means, number 1, the format, all right, inside the bracket must, like it's compulsory, it has to be, it must be 1 plus or minus something. So it can be plus or minus. It does not really matter. Plus or minus something. All right. So for instance, if we are having, you could have something like 1 plus x raised to the power minus 2. So you see it's 1 plus something, or you can have 1 minus 2x raised to the power 2 over 3. Can you see? So you see that one of the variables must be positive. Now, in the previous video, when we're talking about a plus b raised to the power n, I talked about this in the previous video. There was no rule. A can be anything, b can be anything, provided that n is a positive integer. But when it's negative, it has to be 1 plus something, okay? Now, the second rule now, okay? Peradventure, let's assume you have a particular question and it's not 1, okay? What do you have to do? You have to factor it out regardless and apply the laws of indices. Is that okay? So let's say if there is something, let's say there is something other than 1. So that means it could be any other number, okay? Other than 1 in the brackets, okay? What you have to do then is that you have to then factor it out, okay? So that means the coefficient, that is the number that is you're having there, the coefficient must be factored out, okay? So you must factor the coefficient out, okay? So the coefficient must be factored out. So for instance, let's say we have 2 plus 4x raised to the power minus 2, okay? So that means I can write this now as, I can break this down to be, I can factor this. So I can rewrite this as 2 plus 4x raised to the power minus 2. Do you agree? Then I can also say that this is the same thing as saying 2 into bracket 1, because when you factor that out, it's going to be 1 plus 2x raised to the power minus 2. Okay? And remember, in the laws of indices, where we say am raised to the power, ab raised to the power m is equal to a raised to the power m and b raised to the power m, if you remember this rule from the laws of indices. So I'm going to have a video on laws of indices. Please try as much as possible. If you're not conversant, I think you go to the playlist, should be under arithmetics. Then you will see lots of indices there. All right. So when you see this, so this applies to the same thing. So this is our A and all this is our B. So it's going to give us 2 raised to the power minus 2 multiplied by 1 plus 2x raised to the power minus 2. So you can see now we are back. So that means you solve this part as you would have solved it in rule 1. Okay? So that means no matter what happens, you must ensure that, okay, you must ensure that in the bracket you have 1 plus or minus something. Is that okay? Then when you've either gotten 1 or you factorize it, then you apply the formula, okay? So you can apply the formula depending. So the next rule is to apply the formula. So the formula is pretty easy, okay? So if, for instance, you have the first bit of the formula, so is when you have the 1, so plus bx raised to the power n. So bx is the x and b is the coefficient, okay? So that's what it gives. It's going to be 1 plus n bx plus, the next one is going to give you n minus 1, okay? So when you get this, you keep on subtracting 1 and keep on adding it to the factorial. So it'll be n minus 1 bx all raised to the power what? 2 divided by what? 2 factorial. Does that make sense? Plus, you keep on doing the same thing. It's going to be n minus 1, n minus 2, bx raised to the power what? 3 divided by what? 3 factorial. And you keep on going all the way till infinity. Is that making sense? So it's going to be basically n minus 1, n minus 2, dot to n. Let me clean this all the way. Let me see if I can make it smaller so I can have more space. So you keep on going all the way to, okay, you keep on solving to be n minus 1, n minus 2, all the way to n minus r, then bx to power of r over r factorial, okay? So you keep on going, it does not stop. So this is going to be all the way to the end. Now, but if, for instance, in this case, you have a plus bx to power n. So remember, we told you the first thing you have to do is to factorize it, okay? So it's going to be exactly the same thing, but because you have to factorize, so it's going to be the first thing you do, you take a out. So if you take a out, so it's going to be a into brackets. So it'll be a raised to the power n, or do you want me to put it this way so it will be easier for you to understand? So let us factorize this out. So like I said, it's going to be a into brackets 1 plus b over ax, can you see, all raised to the power n. Is this making sense? So because we just the same thing I did here, the same thing I'm doing here. So if you multiply a times 1, it will give you a times b over a is going to give you b. So you see that at the end of the day, you still have the same thing. Then it's going to be a raised to the power n multiplied by 1 plus b over ax all raised to the power what? N. Now, if we have that, then we can now apply the formula. Is that okay? So the same thing, apply the same formula. We expand the one in the bracket now. So let me start from the beginning so I can have enough space for that. So that means what is going to happen here is the a raised power n is going to be outside, okay? We're going to apply the formula. So the same way we say 1 plus bx. So instead of having bx, we're going to have b over a. So it's going to be 1 plus n. Now bx is going to be b over what? Ax. Then the next one plus is going to be n minus 1. Then b over ax raised to the power 2, 6, divided by 2 factorial plus the same thing, n minus 1, n minus 2. Instead of having bx, we're going to have b over ax raised to the power 3 divided by 3 factorial plus dot, dot, dot. Same thing, n minus 1, n minus 2, dot, 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 n minus r. So having bx, we're going to have b over ax, right? Raised to the power what? R divided by what? R factorial. And that is that. So remember, I told you that this does not have a particular endpoint. So it's like it's going to keep on going till infinity. And because of this, it's very important that we know this, because this series does not tend to end. So you keep on going to infinity. And that is the reason why you have to have usually they ask you to give out maybe the first 7 terms or the 8th term, or they can say the 6th term is used to solve a particular questions and the rest of it, but they can't tell you to solve, write all the possible terms in a negative or fraction. So regardless of how the question will come, this is the 3 rules to make sure you do. When you get the question, make sure that 1 is in the bracket. So it's 1 plus or minus something. If not, you then factorize it, then you apply the formula. Okay. And depending if it was already having the 1, you can use the A. If there was no 1, that is, it was this rule 2, you had to go to the rule 2 stage, then you can use this formula here. Okay. So any of them should give you the answer. All right. So what I'm going to say is take a screenshot of this, okay, or write it down in your notes. In the next video, we're going to do some examples, and we'll see how to apply this to solve a question. All right. So I'll see you soon. And that's, like I said, usually say, if you have any question or there's a particular topic you want me to talk about, just let me know. Put it in the comment section, or you can email me directly, and I'll get back to you. All right. Thank you very much. And I'll see you in the next video.